Hello students, today we are going to see what is Newton's method and how linear approximations are involved in Newton's method. So Newton's method is to find a root of a given equation f of x is equal to 0 as you can see here. So here the function f of x is a differentiable function, that is the derivative f dash x's, and the function f dash is continuous. Okay. And how we are going to start with Newton's method is that we start with a guess for a value x naught, which is such that f of x naught is equal to 0. Okay. So that means we guess with an x naught. That means here we are guessing that f of x naught is equal to 0, a guess. So we are guessing an x naught such that f of x naught is equal to 0. So that is reasonably, this x naught is assumed to be or guessed to be reasonably close to a root. Okay. And then produce a sequence x naught, x1, x2, x3, etc. by the formula. Iterative formula means we can calculate this x naught, x1 from x naught, x2 from x1, x3 from x2, like that. So the iterative formula is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Okay. So that is the step till there. And then if limit n tends to infinity xn is equal to x bar, then f of x bar is equal to 0. So this is how the Newton's method is stated. Let's just explain what we have said now. Okay. So at the end, till here it is okay. It is just the steps we have to understand. That is, we are given an f of x naught, f of x is equal to 0. So you have to guess an x naught such that f of x naught is equal to 0. Okay, so given f of x is equal to 0, you have to guess an x naught. Then find x naught, we already know x1, x2, x3, etc. using xn plus 1 is equal to xn minus f of xn divided by f dash xn. So these are the steps till here. Okay. And then we have a sentence which says that if limit n tends to infinity xn is equal to x bar, then f of x bar is equal to 0. So let's go to the explanation as we said, as we mentioned. So suppose, as in the statement, in the last statement, if limit n tends to infinity xn is equal to x bar. So we are assuming that limit n tends to infinity xn is equal to x bar. And we already have the formula xn plus 1 is equal to xn minus f of xn divided by f dash of xn, the iterative formula of Newton's method. Now you are going to apply limits on both sides. So limit n tends to infinity xn plus 1 is equal to limit n tends to infinity xn minus f of xn by f dash of xn, right? And limit of a minus b is equal to limit of a minus limit of b. So here you get the right hand side, you get limit n tends to infinity xn minus limit n tends to infinity f of xn by f dash of xn. And as n tends to infinity, this xn plus 1 and xn are behaving the same, right? So we can say that limit n tends to infinity xn plus 1 is x bar, and limit x tends to n tends to infinity xn is also x bar, as we have assumed that limit n tends to infinity xn is equal to x bar, right? We have assumed so. See, we have just supposed limit n tends to infinity xn is equal to x bar. So that's what we have used here. Okay. So you have x bar here and here. So you can take this x bar to the right and this limit to the left. So what you get here is limit n tends to infinity f of xn by f dash of xn is equal to 0, right? Now, suppose this part here is called as an. Okay, so you can rewrite this as limit n tends to infinity, an is equal to 0. Okay, so this can be cross multiplied to get f of xn is equal to an into f dash of xn. So you can apply limits on this equation. You get limit 10 tends to infinity f of xn is equal to or limit 10 tends to infinity an into f dash xn. Limit of a into b is equal to limit of a into limit of b. So you are applying that property here. So here you have limit 10 tends to infinity an into limit 10 tends to infinity f dash xn. So here we are assuming that both the functions f and f dash. From the Newton's method, we know that we have assumed the function f has the derivative f dash and f dash is continuous. So here we are assuming f and f dash are continuous. F being a differentiable function, obviously f is a continuous function. So since f and f dash are continuous, we can take the limit inside the f, that is a property of continuous function and limits the relation between them. So this equation is rewritten as f of limit 10 tends to, so this limit is taken inside here. Okay, so f of limit 10 tends to infinity xn is equal to, already know, we know that limit 10 tends to infinity an is equal to 0. So you have, you can substitute instead of this, you can put 0 into, here you can write f dash of limit 10 tends to infinity xn. So totally you get, here this is assumed to be x bar. So f of x bar is equal to 0 into f dash of x bar. So this right hand side will be 0. So you get f of x dash x bar is equal to 0. So at the end where we have written this statement, we just proved this statement. Okay, so the explanation is for this statement. Okay, so the explanation is an end there. Now we will move on to a question. Use Newton's method to find a positive number x such that sin x is equal to x by 2. So this is the question. So let's see how we can approach this question. Okay, what is the technique we have to use on this question? So first of all, you have to take this x by 2 to the left. So you have sin x minus x by 2 is equal to 0. You call that as a function f of x. Okay, we are letting f of x is equal to sin x minus x by 2. So correspondingly, f dash of x will be equal to cos x minus 1 by 2, right? And we already know by Newton's method that xn plus 1 is equal to xn minus f of xn by f dash of xn. So here you will have a sequence x naught, x1, x2, etc. be formed. First we will guess x naught, right? And then these are formed. That's how the steps of the Newton methods are going. Okay. So here in this question, you can just substitute the f of xn and f dash of xn. So here you have xn minus f of xn will be sin xn minus xn by 2 divided by the derivative will be cos xn minus 1 by 2. So you just take the LCM in the denominator, which will be cos xn minus 1 by 2, multiply that with this xn, so you get xn into cos xn minus 1 by 2 minus sin xn minus xn by 2. Now open the braces on the numerator. You can cancel out xn and minus xn here, and what remains is 2 into xn cos xn minus sin xn divided by 2 into cos xn minus 1. So here, since we have this sin x minus x by 2, our first guess will be x is equal to 0. So, no, x naught is equal to 0. So, if we assume x naught is equal to 0, x1 using the iterative formula, x n plus 1 is equal to xn minus f of xn divided by f dash of xn. You are using this iterative formula. So if we are guessing the first one, x naught is equal to 0, then automatically the value for x1 will be 0 from what we have obtained here. Okay, you can just put the values. This is, we have just simplified this xn in this question. So here you have xn plus 1 is equal to twice xn cos xn minus sin xn divided by twice cos xn minus 1. So here when you substitute x naught here, that will become 0. So you have x1 to be 0 and automatically x2 is equal to 0 and so on. So that was a first guess. So we know that 0 is already a root of f of x is equal to sin x minus x by 2. You know that when you substitute 0 here, then f of x will be 0. Okay. But what we need is a positive root. Okay. So I'm just guessing x naught is equal to 6. I'm just putting x naught is equal to 6. So you have to use your calculator, and from the iterative formula we have just mentioned, you have to find x1, x2, x3, x4, x5, x6, etc. up till x10. Okay, using the calculator you can form all these values. Just reminding you that you should properly use your scientific calculator, otherwise you might get errors while calculating all the sequence, all the terms of the sequence. Okay, so we obtained values like this. Then you can note that this sequence is actually not approaching any value. See, first value was 13 point something, second value was 30 point something, the next value will be 176 point something, the next one is 448 point something, x5 is 266 point something, x6 is 143 point something, x9 except x9 will be minus 759 point something, x10 is 3572 point something, but it is not actually approaching a value. So we understood that taking x naught is equal to 6, that guess was not a good idea, that was actually a bad idea. Okay, so since we are not getting an approaching value, so let's try to make a better guess. Suppose if x naught is equal to 3. Okay, then what you get from the usage of scientific calculator, you get the terms of the sequence x1, x2, x3, x4 till x8 to be like this. First one will be 2.08 something, second one will be 1.91 something, x3 will be 1.895 etc. X4 will be 1.895 49428, x5 will be 1.895 49427, and from x5, x6, x7, x8, all of them are giving us the same answers. That means all of them, all the values of this sequence are moving towards just one value, which is 1.8954947. So if we substitute this value in our f of x, that is sine of this value minus the value by 2, when you try to find the difference, you get that the difference is very close to 0. Okay, so that means this f of x is approximately 0. So the value which we took as a guess, that is x naught is equal to 3, was a good choice. Okay, so here we will say that the value x which got approximated to 1.8954947 is actually a root of f of x is equal to sin x minus x by 2, and that is a positive value. So that's how we used Newton's method to find or approximate a root or 0 for a function which is given. So you can just work out. I'm giving you a work. You can work on by putting x naught is equal to 6.99, and then you can find x1, x2, x3 up till x8 using your calculator. Similarly, take x naught is equal to 7 and do the same. X naught is equal to 7.01 and do the same, and see if there is